Hello and welcome to this special Horizons event from Wood Mackenzie. This is a monthly series of thought leadership author Ask Me Anything events, and I will be your host. My name is Gavin Thompson. I'm the Vice Chair for Energy for Europe, Middle East and Africa at Wood Mackenzie. And I'm delighted to be joined today by two of my colleagues from our energy transition research and consulting teams, and also a special guest speaker from the Green Hydrogen Organization. So please allow me to introduce them. Firstly, Flor de la Cruz, Principal Analyst, Hydrogen and Derivatives, and the author of last month's Horizons, and Wei-In, Managing Consultant, Power and Renewables Consultant, Asia Pacific. And both Flor and Wei-In are based in our Singapore office. I'd also like to introduce Sam Bartlett. Sam is the Director for the GH2 Standard and the CEO Roundtable at the Green Hydrogen Organization. Sam is an Australian, but he's based way up in northern Norway. So a warm welcome to you all for joining me today to discuss WoodMac's February Horizons Over the Rainbow, why understanding full value chain carbon intensity is trumping the color of hydrogen. The plan for today is, rather than go through the horizons in depth, which of course you can read on woodmac.com/horizons, but rather to have a wide-ranging discussion around the topic, to hear alternative views to the WoodMac position, and to challenge our views on this really critical topic. So thank you again for joining us. And without taking any more time, I'm just going to dive straight in with my first question. So Flor, I want to begin with you. And I want to begin with a very open question around what motivated you to write this analysis for the Horizons. You're saying we're over the rainbow, but what are the hydrogen colors in the rainbow? And really, what is the issue with using colors as a definition for different hydrogen production processes?
Thank you, Gav. Yeah, so every day I look at hydrogen and derivatives. And I mean, the reason why hydrogen is very important, just to remind everyone, is, if we are to reach net zero, hydrogen is going to play an integral part of that story. So the hydrogen market today is a little under 100 million tons. Most of that is carbon intensive brown or gray hydrogen. But in our base case, we forecast that to reach about 270 million tons by 2050, and 200 million tons of that will be low carbon hydrogen. And here's where it starts to get a bit tricky, right? In our net zero scenario, we forecast that we'll need about 500 million tons of low carbon hydrogen. But what is actually low carbon hydrogen? A lot of people discuss or always talk about green hydrogen made using renewables and electrolysis. Then there's been lots of discussions about blue hydrogen. And then you start getting into very muddled waters when you start including nuclear-based hydrogen, turquoise hydrogen, and the rainbow can go on and on and on every time someone discovers a new hydrogen production pathway, pyrolysis, waste gasification, etc. So to simplify things in a way, what actually matters with all of these different pathways, if the goal is to get to net zero, then what's really important is that carbon intensity. And the common idea, or what's kind of understood, is that green hydrogen, or hydrogen made from electrolysis pathway, will have nearly zero emissions. And that blue hydrogen, although not as close to zero, could be around maybe 4 to 8, depending on how much CO2 you capture. But is that really the case? So once I started diving into the data and to the upstream emissions for blue hydrogen, and potentially the grid emissions for electrolysis-based hydrogen, if you were to connect to the grid or use some grid electricity, then the picture looks very, very different. And that's the story I tried to highlight in this piece, that maybe we should be scrutinizing these pathways a bit more and not just applying blanket colors to different things and ending up with maybe false conclusions that one is better than the other.
Okay, so Sam, I'll allow you the rebuttal here. So, GH2, green hydrogen, you do use colors. Your organization is clearly named and driven by green hydrogen. So why would you continue to use color labels? Where's the value in that?
Yeah, thanks, Gavin. I guess we agree and we disagree. We of course agree that the carbon intensity of the different hydrogen pathways is crucial, and that's something that there's been a lot of work done on that by the IPHE. It's now being turned into an ISO standard, that covers, it's technology agnostic and covers lots of different pathways. We think that work is really important, and we need to make sure that when we talk about the carbon intensity, that measurement is done in a rigorous way. And maybe that's something that we might dive into today. We're not over the rainbow. We still refer to green hydrogen and blue hydrogen for a number of reasons. One of them is that while emissions are important, there are other variables that we think need to be interrogated as well. Blue hydrogen continues to depend on fossil fuels. One of the big takeaways from COP is in a global agreement that we need to transition away from fossil fuels. So one pathway continues the sort of reliance on fossil fuels, whereas green hydrogen frees us from that. The different pathways have different levels of technology readiness. We've been doing electrolysis for decades, whereas some of the carbon capture and storage technologies are unproven. There are different economics, different incentives, and then finally, an issue that we focus a lot on is that the different pathways have different outcomes in terms of their ESG performance and the development impact. So, of course, hydrogen is colorless. There's no such thing really as green hydrogen or blue hydrogen or pink hydrogen. But those labels denote different production pathways, and they denote different choices that policymakers and industry have to make. So we think that the rainbow is a useful framework for interrogating those choices.
Great, thank you, Sam. Flor, we're going to talk a lot about green today and a lot of the issues and opportunities, but I wanted to stick with the colors and talk a little bit about blue. So when we look at our long-term outlooks, we see green hydrogen as the winner if you were picking a color. Look, it's expensive today, but innovation, scaling up in technology should make it competitive. We will probably agree with that. But if I look at our analysis on blue hydrogen, we have some pretty surprisingly low numbers there on carbon emissions. I think we have about 0.5 kilograms CO2 equivalent per kilogram of hydrogen. With CCS, of course. Last week, I was speaking to a very big national oil company who were very, very positive around the role of blue hydrogen, blue ammonia. Sam made a very clear point that the COP28 agreement says we're moving away from fossil fuels, but when I look at the costs and the potential competitiveness and the carbon emissions and intensity of blue, are we discounting blue, or is there a role here for blue hydrogen?
No, there's definitely a role, and the advantage of I guess just the production, again, not the CCS, because as Sam pointed out, that is still to be proven. The production step itself has been proven can provide that scale, and that's why those economics look very, very favorable. But 0.5 is a very, very low end, and it's almost like the golden standard. The reality is not 0.5 kilos of CO2 equivalent per kilo of hydrogen. It's probably more towards 6 or 7. And the reason for that is because most of the projects in operation today aren't capturing, 90+% of the CO2 emissions from the reformer. They're capturing around 60% because it's a lot cheaper to do it that way. They're retrofitting CCS units with existing reforming units, and as we mentioned earlier, that's unproven technology. So on paper, you could potentially catch 60%, but the reality is a bit lower. So it begs the question: do you make that investment now with that uncertainty on whether you could actually achieve those really, really low rates, or do you kind of just place a bet on green hydrogen? It can provide scale, but can it actually provide that 0.5 low limit? We're not so sure.
Okay, so that is that's the bottom line, I guess 0.5, but there is a range in the horizons.
There's a
And in
range.
terms of technology as well, different technology choices, ATR versus SMR, is there a preferred tech, which has the lower emissions, and why would that be?
So this is a really interesting question because a lot of the conversation around blue hydrogen was that you would switch from steam methane reformers to autothermal reformers because it is seen as a lot cheaper to capture that 95% of CO2 emissions plus in an ATR unit. Just as a reminder, most of the units in operation today are SMR units. So you would be deploying new ATR units. So yes, it is cheaper in theory to capture 95 from an ATR unit. But when you look at the emissions, this is the really interesting point. Because an ATR unit does use substantial amounts of electricity for the air separation unit, which the SMR does not. So if you were to compare an SMR unit that was capturing 95% CO2 versus an ATR unit capturing 95% CO2, both connected to the grid to provide that parasitic load for the unit, then the emissions from the ATR would actually be higher.
Okay, I see. So this is an evolving topic. Now, I'm really interested in blue hydrogen and ammonia, but we want to move away from this, otherwise I'll take up all the time.
Gavin, I wonder if I could just jump in there because
please do, Sam.
I think Flor's mentioned a really important point, and we're going to come onto it with green hydrogen. We're using electricity in an ATR process. Where does the electricity come from? And we're going to have that question about green in a moment. But I just want to touch a little bit on when people talk about blue hydrogen, we almost always fixate on CCS and whether it's 60% or 90% or 95%. Very, very important point. But there's another aspect to it, and that is the upstream methane emissions. And there is a really important issue that needs a lot more attention. In some places, in Norway, for example, you have quite low methane leakage associated with the natural gas value chain. And that is a big part of why some of the blue hydrogen producers here in Norway think that they can get down to a very low number in terms of total emissions. But in other places, in other gas fields, you have very large methane emissions. And this is a problem that we've known about for many decades. But some of the standards that are emerging now say that, well, you can just use a national average for methane emissions, and you can put that into your calculator. We think that that's ridiculous. There should be site-specific measurement of where your methane comes from and where the methane leakage is, and that should be reflected in the total emission intensity. The other issue is what happens to the carbon. So we do need to look at the question of the permanence of carbon removal. Is it being permanently stored, or if it's being put into a reservoir and it leaks 10 years later, well, that's not helping. So we need to look at those three issues: upstream methane, CCS, and then downstream carbon capture and storage. And those things need to be looked at on a project-by-project basis. And there needs to be rigorous independent oversight of that. Otherwise, people can say that their emissions are low when really they're not.
Yeah, Sam, I couldn't agree more. And I think methane, it's one of the hot topics. And if you look at the US, there is obviously methane emissions at the upstream production, but then if you also consider gathering and boosting through the pipeline system, the US has 2.4, I think, million miles of pipelines, almost the same as its highway network. So your point is very valid. I'm going to move on and talk about certification. So certification, really critical. If the buyer is understanding what they are actually going to be taking hold of for governments around incentives, subsidies, and so forth. And so, Sam, I'm going to stick with you. What are the challenges around certification? How are we progressing? How do you see that in your work in terms of really solid international recognition around certification, which is bankable and which push the industry forward?
Yeah, the biggest challenge is that that there are, the first thing that Flor said is that this is a big existing industry. We have a lot of standards when it comes to, the quality of hydrogen infrastructure, hydrogen storage, health and safety standards. What we don't have is international standards when it comes to measuring the carbon footprint and when it comes to some of these sustainability issues that I mentioned earlier. If you're a customer and you want to prove that you're decarbonizing your business, you need to demonstrate that the hydrogen that you're using, or the ammonia, or the methanol, or the SAF, lots of other derivatives, you need confidence that what you're buying doesn't come with large emissions, so that you can count that towards your decarbonization targets. So those standards and certification systems, they are being developed, and they're being developed at the national level, on the global level, and there's a bunch of questions about how they'll be harmonized, especially when it comes to international trade. So we're not starting from zero. We can stand on the shoulders of an existing hydrogen industry, but we need to build on some additional variables to that sort of value chain of certification, so that the customers and ultimately the consumers can have confidence that they're buying a product that has good climate credentials.
So on that question, Flor, Sam has stressed the importance, the essential nature of certification. Low carbon hydrogen is not yet low cost. This is one of the challenges. So how often would a project have to certify it? What is the cost of certification? And do you need multiple certificates if you're targeting multiple markets that may have different levels of standards and quantification of carbon intensity?
No, that's a fair point, and that's something that we're asking ourselves, especially on Sam's point. There is an effort to harmonize, and there is a call in industry that we need a harmonized system so that you could avoid this multiple certifications. But the reality is that there are two major import centers emerging. That's the European Union and Japan and South Korea. And they have a very different view as to what is considered low carbon hydrogen. And there are very different rules on incrementality, temporal matching, production pathways, and threshold, and more importantly, emission scope. So whether you stop at the hydrogen gate or whether you also include emissions from a derivative that you use to transport hydrogen. So ammonia emissions, ammonia shipping emissions, ammonia cracking emissions. So what does this mean for a developer? And this is something we're asking ourselves, that's trying to target two markets. What if their hydrogen does meet the standards for both the EU and the Japanese market, which is a bit more pragmatic and only looks at production? Do they need two certifications? And how often do they have to certify that? You could argue that once you've certified today, that should be enough for the next 5 or 10 years, because for the most part, emissions of power grids are going down everywhere around the world. But in very certain cases, such as like India, China, they're still deploying coal. And there's additional coal that will come online. So you could actually see your emissions rise in a few years and before they start coming down again. Or in markets that rely heavily on hydro, such as Brazil, they may need to draw on fossil fuels if there's severe droughts. So yes, that will be an added cost, and it's something that we need to start looking at to see what impact that'll be.
Yeah, it does seem a big challenge. Wei-In, I want to turn to you now. So, we've been talking about certification. We've been talking about, effectively, how green is green hydrogen, and where is the standard. One of the key issues, for electrolytic hydrogen to be truly green, developers argue that they that if they purchase green PPAs, if they have a grid connection, that they are producing green hydrogen or are able to produce green hydrogen. Is that really possible? In which markets is it a reality where a truly green PPA can allow you to then produce green hydrogen? And are there sufficient PPAs in the market to meet rising demand?
First of all, I think if you counted your green PPA as annual offset, if you're doing a virtual PPA, yes. I think in some market, more liberalized market, you can claim that you're actually true green. But then let's say more and more companies and markets are going through 24/7 and they want your production really match the generation, then in this case, that's going to be a lot of challenge, because for each kind of renewable technology, they generate in different time of the day, of the season. If you really truly want to match your consumption of your electrolytes, that would probably means you need to have a combination of solar, wind, hydro, and even battery. And then on top of that, you have to work with a developer to have intermediary to broker the surplus energy to the wholesale market. So I just truly see the challenge here. And on top of that, if let's take an example of Europe, I think you also have to fight your green PPA with other corporate taker. Because, for example, last year we're seeing nearly 75% of the PPA signed are corporate PPA.
Okay. This is something I struggle with when I look at power supply. So for the economics of green hydrogen Wei-In to make sense, electrolyzers need to operate at something like I think around about 70% capacity.
Yeah, 70%. But
okay.
Usually, if you sign one PPA, that could bring you somewhere like 20 to 30%. So let's take the H2 Green Steel as example. The first PPA they signed that would supply 30%. They have continuously signed a second PPA, but which they have not revealed how much percentage can actually support their electrolyzer to work.
Okay, so that's a pretty high load factor for for a pure renewables offtake. So can a green PPA truly provide that load factor? That's my first question. So maybe if you want to take that one, then I'm going to follow up with the second question on this.
I think it's challenging. It's very challenging, and you really have to understand your energy consumption and understand how each tech can matching with you. So far, I think Europe is probably the only one market that would be possible, but it requires a lot of effort, and it requires a lot of simulation, and how do you handle the surplus energies together with your developer. So giving all these things together, I don't think at the moment the developer with electrolyzer would be able to really quantify the economics. If, let's say, they want to have 70% load factor or even going more aggressive. And on top of that, according to the EU regulation, we understand so far, your PPA has to be new project, has to be connected to the grid.
Yeah, so that leads on to my second question. But actually, I might turn to you, Flor, because we discussed this when you were working on the Horizon. So if we look at PEM electrolyzer technology, okay, you can operate with with some relative intermittency. If you look at alkaline electrolyzers, okay, you're going to need grid backup. Now, the question which you posed, and I want to ask you again, is if we see more alkaline tech with more grid connectivity, which is not 100% decarbonized, are we going to get a two-tier green hydrogen market? Are we going to get something that isn't what it says on the tin, perhaps being cheaper, but being sold into markets that have lower certification or standardization? We're seeing this, for example, we might see it in other sectors where you've got a European premium and then you have a emerging economy discount. Where are we going with this?
That's definitely where we're going with this, especially where I'm sitting here in Singapore and covering the APAC market. We are seeing Chinese OEMs who are primarily focused on alkaline technology, which doesn't provide that intermittency or that variable load that maybe a PEM electrolyzer could offer. They're also a lot cheaper. That's the key, right? The cost is maybe 30 to 70% lower than a PEM electrolyzer. but they do need that continuous electricity source. So if you're going off grid, then you have to start adding in some batteries, oversizing your equipment, and then your economics start to look very, very unfavorable. So then what you could do is have a grid connection to provide some sort of base load. And one of the reasons these electrolyzers needed is to essentially operate safely. So it is really a safety concern. And moving on, and I think, again, this is why we need to look at the whole project a lot of times. Sometimes we look at the electrolyzer and we say, this one can operate, that one can't. Okay, once you've moved on from the electrolyzer, your compressor can't operate on variable load. That is very dangerous. And a lot of safety equipment at the facility cannot operate on variable load. So if you're truly going to include the emissions of the entire facility, then we're talking about a parasitic load, grid connection, and there might not be a way around it.
Well, we're getting into the detail, right? And we're emphasizing the challenges. But let's not get overly negative. There are huge opportunities. We have an audience question, Sam, around the renewable sources that are best suited to green hydrogen practices. Now, you're in Norway. Norway has an incredibly privileged position. Not everybody is going to replicate Norway's excess hydro availability. But if you're advising and you're looking at projects, what sort of renewable optimization do you see as the best opportunity for green?
Yeah, there's no one size fits all answer to that. We do see there are some, and this is recognized in the European regulations. There are some grids that essentially decarbonize. So it's not so much of an issue if you're taking electricity from the grid, because the grid is already 95, 97% green. And hopefully, we'll get there in a lot of other markets, and perhaps a lot quicker than some would expect. That's been the direction of travel, the encouraging direction of travel in the last few years, especially as the costs of solar have come down. We also have a number of project developers who we're working with. They are off-grid. They have their own dedicated renewables. They are looking at utilizing batteries and other energy storage options. They might have a grid connection as a sort of backup, precisely to address those kind of health and safety issues that Flor was just talking about. And then you have the projects in the middle, which are connected to the grid. They might have a combination of their own dedicated renewables and a PPA that comes with renewable electricity certificates. And that's one of the things that we look at in our work under the Green Hydrogen Standard is, what is the impact of those projects and what steps are being taken to secure the required supply of renewable electricity, and what is the impact of those projects on the grid. So there is no sort of one size fits all solution. You need to look at questions like, well, if you have increased demand on the grid, where is that additional supply likely to come from? Is it going to come from for example, the development of more wind power, or is it going to come from keeping coal-fired power stations either bringing new ones online or extending their lifetime? The last thing I'd say about that is that that's a very difficult question to put in the lap of a single consumer. This is a grid level challenge, and this is something, so it needs grid level solutions. The really challenging task is for the regulators or those that are managing the grid. They need to match supply and demand every millisecond, and the tools that we have today in the market, and this comes back to your question to Wei-In about is the market ready? No, the market is not ready. You have some of these renewable electricity certification instruments that are annually matched. That is borderline meaningless. If any electricity user wants to say that they're using zero carbon electricity, then they should be using 24/7 hourly matched electricity, and they should be buying RECs and contributing to the development of that market. At the moment, we're saying to the hydrogen industry, which is a newcomer, you need to develop these instruments, in order to be part of the market. And I think that that's the challenge. Is that that's likely to be very ineffective. The best way to address a grid level problem is with grid level solutions that apply to all consumers. And that means that anyone that wants to say they're using green electricity will use the same instruments, and then we can develop a deeper market for those products.
Yeah, it does strike me as the sort of putting the blame or the onus on the customer rather than on the supplier, which is not particularly normal. But
other customers. You could have
other customers.
Someone today could say, "Hey, I'm going to put my Bitcoin mining operation up here in northern Norway, or I'm going to build a supercomputer because I want to work in AI." That uses a massive amount of electricity.
Yeah.
And they can greenwash. We can greenwash those operations and say we've bought an annually matched REC. I mean, that shouldn't be accepted or tolerated. So we need better rules for all electricity users, and we should apply them to the green hydrogen industry as well.
So Wei-In, why are RECs out there? I mean, are these lower cost alternatives to PPA? What's driving their interest from consumers?
First of all, so REC is a very interesting idea. So some of the organization and initiative take REC as a reporting instrument. So if that is used as a reporting instrument, it could be bundled or unbundled. So like what Sam said, if you are buying very cheap unbundled REC annually to offset your emissions, that's pretty much meaningless. But let's say if you are signing an actual PPA and comes with the bundled renewable energy certificate, that means you as a consumers are actually helping building more renewables. So there's a very big different distinction on that. And then on top of a PPA, so if we were really going to the strict requirement 24/7 matching, this is what the current REC cannot do. And we've seen a lot of PPA signed these days are actually virtual PPA. So you're helping the developer to build more renewable, and then in exchange, you get renewable energy certificate. This is, of course, not ideal, but it's at least the consumers are actually helping to bring more renewable energy project online. That's so a grid level issue. To be honest, for a lot of consumers, it's already very challenging for them how to step into procure energies and understand very complicated energy procurement contracts. Then on top of that, a lot of people are also saying renewable energy costs are going down, which is if you're not looking at network or grid infrastructure cost. Because at some point, let's say if the market operator cannot take, it's all gonna come back at some point to the consumers and the developer.
Right. So we're seeing the levelized cost of renewables coming down, but of course that's not necessarily delivered cost to the consumer. We are getting into our time here, so I've got a couple more questions before I throw out a surprise question. And perhaps Flor or Sam, I mean, happy for you to share this one. We have a question around the EU consensus about value chain emissions thresholds. For green or blue hydrogen. I think probably perhaps more focused on blue, although of course we have seen blue ammonia shipped into Germany, for example. I might add on. I might embellish this question slightly, because whilst we've seen EU agreements recently on, for example, methane regulation, the the 2040 recommendations are going to be quite a big issue. I think in the June European Commission elections, populist parties tend to sort of say these have a negative effect on industry, on agriculture. Is there genuine European Union consensus on full value chain thresholds to be truly defined as a green hydrogen product?
Sam, why don't you take this one since you're sitting in Norway?
Right. So I'd answer that in two parts. And it comes back to where Flor was started, that we need to look at the full value chain emissions intensity of hydrogen production pathways. Definitely, I think Europe is doing better than most on that. If you look at the rules defining renewable or green hydrogen in the EU, you have to look at production all the way through to consumption. That includes transportation costs, distribution costs, and so forth. In other jurisdictions, it's what they call a well-to-gate methodology. So it's only looking at the emissions during production. So we need to move towards a full life cycle analysis. And we would say that actually that also needs to include, the emissions that are embodied in the equipment that you're using. Now, people like to say that, renewable electricity is zero emissions. Actually, we don't say that, because you need energy to produce PV cells and wind turbines. So there are emissions embodied in that equipment, and we think that should be taken into account as well. So there's work to do in that full life cycle emissions framework, including those sort of CapEx emissions that are embodied in the equipment. The second part, though, is that, we have in Europe quite strict rules defining what is green hydrogen, but we don't have strict rules for blue. And that's coming this year. That's something to watch, and something that we're following very closely through there'll be another delegated act related to the GATS package that will define the methodology that will need to be used to qualify as low carbon hydrogen. So, as with many things, the devil will be in the detail. We'll be watching that very closely, because that will, I imagine that it again will take a full life cycle approach, and we hope it'll look at some of the issues I mentioned earlier. Upstream methane emissions and the permanence of carbon removals are particularly important. But if we're going to look at those CapEx embodied emissions in green, we should look at the same with grey and blue as well. So there has been a lot of work done in this space. We're not starting from zero, but there are still some contentious issues about how to do this consistently. And you're right, there is a concern that the market will kind of fragment between people using very strict standards and others that are using a very narrow standard, with no threshold for what qualifies as low carbon or not. That's another, concern that we have. A lot of standards have no thresholds. It just says, here's the method for how you measure, but we're not going to have a threshold for what qualifies. I mean, that's not good enough. We need to get to net zero. So we need to set targets. We can't just say this is how we measure and we'll let the market decide where the threshold is.
Yeah, I think that's very valid. Flor, I don't know if you have anything to add on to that.
No, I think he's covered it quite well. It will be a challenge, and from what we understand, there is pushback in the EU on it. But at the end of the day, the rules are the rules, and other jurisdictions will come up with slightly more lenient ones.
Okay, thank you both. A final question from the audience, and Wei-In, I might start with you on this, but please, everyone else pitch in. It directly refers to Asia Pacific, and it's a question around how we see the price related to the carbon intensity of hydrogen ammonia in Asia going forwards. Whether it's just going to be a linear sliding scale or something more structured, as we've seen and we've just been talking about in Europe and in the US with the Inflation Reduction Act. Now, it's a very difficult question to answer because Asia Pacific is not one homogeneous area with one set of rules, but maybe you could take a slightly more fragmented approach to how you see price relating to carbon intensity in the regions.
I think so far I haven't really seen any countries who are interested in hydrogen come up with their actual carbon tax related to it. So I think that's a bit challenge to say. The projects for hydrogen in Asia, it all comes up with pre-aligned offtake agreement or certain, I would say, for example, the project in Malaysia, I'm pretty sure it's backed up by government-related body. So I don't really see the commercialization goes so far compared to other more mature market yet.
Okay, Flor.
Yeah, I don't think this will be weighted towards a fully green IRA fit for 55. It is,
No.
we're starting to see a different market emerge here. And I mean, it's a region that's growing very, very fast. Certain markets are growing very fast in terms of power demand. Historically, they're still relying on coal. LNG is seen as a transition fuel, and those themes will remain, at least for the foreseeable future, especially for developing economies. So there is more of a pragmatic approach, and you'll have two different markets emerge where cost is more important than emissions, and that's understandable for the region.
Great, thank you. Final question. It's going to be for each of you. You have to answer fairly quickly because we're running out of time, but that's not a bad thing. But and it's a pretty straightforward question. The challenge is that you can't all have the same answer. So as a guest, Sam, I'll let you go first. So magic wand, what would be the one change, the one thing that you would want to see happen right now to really speed up the growth and the development of green hydrogen and get that market running at full speed?
Well, I can think of a couple, but I want to touch on an aspect that we haven't mentioned today, and that is developing and emerging markets. And that's something that, we often look at the rules that are emerging in the EU and in the US with the 3 pillars and the standards that are emerging in Japan and Korea. There's an enormous potential to leverage green hydrogen production in emerging markets and to help them support their energy transition. They have extraordinary renewable energy endowment, but they have the challenge of sort of bringing those projects online because you need a customer, someone that can pay, that will sort of underwrite those projects. So we are seeing, I'd say the majority of the projects that we're working on are in developing and emerging markets, looking at how you can leverage that both for green hydrogen or usually it's green ammonia or methanol for export, but also leverage those projects to drive the energy transition and address energy poverty in those countries. And that highlights again why, Flor, you said that the colors are so 2023, they're so last year. Colors matter because there are other sustainability and development considerations. And if you just take the EU rules and you apply them in Africa, you get some unintended consequences. So we would say we need to look at those projects, for example, in sub-Saharan Africa and North Africa, and say, how can we leverage this to support energy security, but also how can we leverage them to address energy security and energy poverty issues in those countries. So that's something that we'd like to see. And we're doing a lot of work with development finance institutions. But if I could wave my magic wand, I would love to see, the World Bank, the African Development Bank, EBRD, getting more involved in developing the financial instruments that will de-risk those projects, that will provide energy security, particularly in the export markets, but also develop those modern energy systems in those countries to help them achieve their sustainable development goals. So that would be my, just a small thing, but that would be the aspect that we'd like to see more attention.
Thanks, Sam. Flor, we'll pass the magic wand to you next.
I will piggyback on what Sam is discussing, and what I would like to see actually is more binding targets, because we do have very strict targets in the EU. There's some in Japan, not necessarily binding, but we have over 14 markets all saying they want to export. And in these developing markets where I'm sitting, they want to export 100% of their low carbon product. That's going to be very challenging, both from a supply chain development perspective, because it's going to take lots of years for them to actually develop the infrastructure to export green ammonia or blue ammonia. So if there could be some binding targets in each of these countries that have a huge pipeline for projects under development, then you could actually start to see some of those projects get off the ground. And then eventually some of those volumes will end up in Europe or Japan, but it will address also this energy poverty issue that Sam was discussing. So then some of that benefit can also stay within the countries.
Thank you, Flor. And Wei-In, the final word, over to you.
I guess it's a bit of transportation technology improvement. So the way I see hydrogen is very useful in several ways. You can have it on site for your steel extraction process. You could transport and export it. But so far, I see the cost and the safety concerns of exporting hydrogen. So that would significantly need some help from what Sam said, blend finance and to de-risk and speed up like what we have done for other renewable technology.
Excellent. I'm glad you got transportation in. We didn't spend a lot of time on that, and that's us at our time. So thank you very much for joining us, and a really big thank you to my guests, and in particular to Sam from joining us from an external organization, which was great. You challenged us right from the outset, which was really healthy and enjoyable. Really great debate and discussion on such an important topic. Before we wrap up, just to remind you all that you can read all the Horizon and Thought Leadership pieces and sign up for our weekly insights at woodmac.com/horizons. So please keep an eye out for those, and for LinkedIn for other details of upcoming Horizon Lives events. And this has been a Wood Mackenzie production. Thank you for joining us, and we will see you next time. Thank you.